Okay, I want to thank all of you for coming. I hope you are having a great week with computer science. We have Robin and her son Ramsey here today, and they are going to talk about computer science. And I think you're really going to enjoy this. So have fun. Thank you.
So, hi, I'm Ramsey. And just a bit about me. I'm 14. I'm in ninth grade, and I've been part of competitive robotics for about the past 7 years now. That has included multiple different levels, but that means I've had a lot of amazing opportunities. So, first one was the coding. So, who here has coded before? I can't see your hands, but I still want you to raise them if you've ever coded. So, people tend to code in visual scripting. At least in our ages, we tend to use visual scripting. And a very common form of visual scripting is something called Scratch. Scratch, who here's done it? I know I can't see you, still do it. Scratch is a very basic, what we call block programming. It is drag and drop, so you have all your blocks on the left side and you drag them over and you kind of stack them and it performs a certain code. All these different blocks translate to different syntax and different, well, code. Another version that, if you're familiar with FOL or EV3s, you might recognize this. So this is another form of visual scripting, and this is another form of block-based programming. Now, the difference between these two is that the one at the bottom, it has a lot of different functions. For EV3, it's all about moving motors, weighting, and using sensors, while Scratch is more about key inputs and mouse inputs and where your mouse is. Another difference that you might see is Scratch is top down and EV3 is left to right. Now, something that not a lot of people know is there's another type of visual scripting. It's called node-based scripting, and this is used in lots of video games. This is actually a Unity script. So this is using these different points and these what are called nodes right here, and then the wires that connect them. This is an ability to code without really knowing how to code. It's just using the logic and actual words. So I actually use visual scripting in my robotics. Now this is called yeah, Java blocks. And in this, you might be a little confused what this is saying. But all it's really doing is if we look down here, it says if gamepad B, right? That means if we press the button, then it will set duck, which is a motor. Yeah, it's a weird name, but it does its purpose. But if you notice on the right side, it has the actual Java code. Now, be honest with me, which is easier to read? This one over here, where it says tank left and then the gamepad, or the stuff on the right? It's a lot easier to read the stuff on the left, right? So then why do we not just use visual scripting for everything? Well, visual scripting does have a lot of advantages for it being easier to read for most people and it being able to be used almost everywhere. It has its limitations. And that's where our text-based coding comes in. And today I took a class this summer. It was all about machine learning. I had never programmed in Python before, and I wanted to challenge myself. So I signed up for this class and I took it. Do you guys want to see some machine learning? I found this very interesting. Has anyone heard of AI or machine learning? So here are the two things. The first one I'm going to show you is called a neural network. This is basically how an AI or machine learning script works. So AI is artificial intelligence for people who don't know what it is. And you'll actually see what an example of it with this neural network. And then computer vision is basically using a camera or photos or a video and train and test data in order to identify what's in the photo or in the frame. So we're going to start with the neural network first. So let me close a couple neurons. So for us humans, we can easily see that there is a difference in these colors, yes? You have the orange circle on the outside, but you have a little blue circle on the inside. Now, for computers, it's kind of difficult because, yes, they know that there's a difference in color, but they also don't know where everything's placed. And this, the part that we're seeing is actually what's called train data. And right here, over here where my mouse is, this is all the train data that we have. So we can do up to 90% in order to test. Machine learning and AI is all about three things. You have your training data, which is all the stuff that you input. And you'll see a much easier version of this in the next section, but basically it's your inputs. Then you have your weights, which are the things in the center, which is what you add, subtract, multiply, divide, a bunch of different things that you change. This is actually what your machine learning actually changes in order to get different outputs. And if we ran this right now with the different epochs, epochs is generations of the code, so it's a bunch of different versions of it. After about 90 epochs, we see a distinct change in it. And you see how this is it's pretty simple, right? You have 4 neurons and 2 inputs. But the problem is when you get more complex, like a spiral over here, it kind of struggles. So you can add, I'm not going to do this all, but you can add a lot of different neurons and it gets more and more complex. After a certain point, it's almost just a big thing of spaghetti. You don't really understand what's happening, but the computer does. And if we run it, it should get a bit closer. Yeah, see? Starting to form a spiral. There you go. Now, the only thing that's changing is this test. It's using that 90% of the trained data and using 10% of the data to test it. So it says, I think this is a blue dot, or I think this section is blue, and then it checks if it's right or not. If it is right or wrong, then it adapts its weights in the center. And so now we're going to show a bit of computer vision. And this is a very cool website. This is actually made by Google just to show a basic version of computer vision. So how does it work exactly? Like, how is it getting its data? Well, we're actually going to click this button right here. It's going to take a bunch of photos. So I'm not going to hold anything right now. This is going to be a base frame data. I'm going to move around a bit so it gets a bunch of different angles so it's not messing up a lot. So we're going to get a very small sample size of about, I don't know, 100 photos. So now if you see at the top, it has a 99% reading of it being neutral. So it's just me in the frame. However, if I bring in something like this, it doesn't know anything different. But if I start training it to follow my phone, and do a bit more on the other hand, if I hold my phone up, yeah, it should see confident, and then when I drop my phone down, it goes away. So it's registering the difference between between all the different photos in fractions of a second in order to determine if it is in the photo or not. Now, this can be really big or really small. And you see how the movement of my hands is making it move. That's because we don't have a lot of data. In that machine learning class that I briefly mentioned, we had a data set of over 15,000 images across 4 different types of photos. And then this is the picture of our machine learning script that we just played around with. And so vision can be used in almost anything. And in fact, me and my team, my robotics team, are going to try and use it this year and in upcoming years in order to identify blocks and balls. We aren't quite there yet, but I want to show you something called CAD. Now, if people have heard of CAD, then you'll kind of recognize this. But it's computer-aided design, which means I can build stuff or draw stuff on the computer in 3D space, and so I can see how everything interacts and everything moves. Now, something that's also very interesting is you can simulate a lot of different things with CAD, such as a piston moving, or in this case, a wheel turning, even motors moving. But there are limitations, such as things that are very difficult to calculate, like chain and sprockets. So currently we just have two belts. This is where a belt would be, but our Onshape, which is our CAD software, is unable to register those currently. So now that we know that CAD can build stuff, CAD can also draw stuff. So our robot this year had to pick up stuff. We needed to make a box, a collection box of some sort, but we couldn't find one anywhere, so we had to draw one. So this right here is a drawing that we made using sketches and extruding it in 3D space. This can then be forwarded to a 3D printer and printed out. And we actually now have this piece in real life. And it came from a computer design, which I find very fascinating. And if you want to see it, then in real life, this is what our robot looks like. To put in perspective, these wheels are 6 inches in diameter. This is the box that was designed, and this is the frame that it was sitting on. This part right here is a linear slide, which makes it move up and down. It moves up approximately 18 inches, right? Approximately, by using a pulley system, which you can kind of see on this edge over here. This is also the competition, and this is the robot for scale. And our challenge this year was to pick up blocks and balls and stack them on this wobbling tower. As you see, we're not very good at balancing it because it's very tilted.
So as Ramsey kind of talked about some of the different ways that you can look at coding and programming and designing on the computer, one of the things that I think it's really important and we really wanted to emphasize for you guys is that this is an incredible industry and area to go into. And actually 88% of businesses worldwide plan to adopt some type of robotic animation into their infrastructure from here on out. And already many industries such as the automobile industry, actually medicine, there's plenty of robotic surgeries now. In fact, they said there's about 6,000 robotic surgery components that do about 1 million surgeries every year. So this is an area, any of these areas, whether it's coding, programming, computer vision, artificial intelligence, machine learning, all of these kind of tie into this huge worldwide gap that we're currently having. Go ahead and switch. And there are so many jobs that haven't even been identified yet. So the actual global robotic market has been valued in 2020 at $27.73 billion. And by 2026, which is just actually almost 5 years from now, that is
4 years from now.
Well, 4 years. That is expected to go to $74.1 billion. So there's a huge market and a huge opportunity for individuals to really grow and learn in these areas. Go ahead. And so, you know, there's all these different opportunities and robotic engineering positions. This can be people that work for companies like Amazon or General Motors or any of these different places. They have these new positions for people who have to automate the robot. They do it autonomously. Autonomous would be programming with that. You want to explain that? They have just code.
So there's a lot of different ways that you can code it. So autonomous means that it is functioning off of only the code and maybe a couple sensor inputs. So if you have let's say a gyro sensor, your computer vision program, if it identifies a box or an object, it can move autonomously by itself towards the box, pick it up, and do whatever action it's supposed to do with it.
So there's a huge area, and a lot of the warehouses simply now program the robots to go pick up boxes or to go find materials automatically or autonomously at the beginning of the day. And no one ever touches them. So having these coding skills is a really critical component of that, right? And they're actually saying that this job field is going to grow anywhere between 5 to 9% a year. So by 2026, they are going to anticipate having 9,500 job openings in just the robotic engineering positions alone. So another huge area for robotics and programming really is the military, right? And if you look at all the drones and different things that the military is doing now, there's a huge market and there's lots of dollars and opportunities for learning in this area. Go ahead. And so, you know, maybe you wonder, well, what kind of degree might I want to get if you are interested in robotics? You know, electrical engineering is a great one because you're learning how to wire everything. And that component can help with the energy, right, of getting things to move around. Mechanical engineering has everything to do with sort of the movement and how things worked and how things work together. Your computer science, your vision, your coding, and all of those different things are part of it. And mathematics is another huge area. You know, math plays a huge role in everything that you do. You want to talk about how math plays a role in, well, I can give an example. Ramsey goes on a regular basis to a machine shop, and the machine shop design, you know, those 3D parts that he did. Well, they maybe will do those, design different components in different types of metal or materials.
And they have to calculate it to the, what was it, 100th? No, it was 1,000th of an inch, which
to be accurate.
Yeah, in order for it to qualify as accurate to their models. 1,000th of an inch is a very, very small amount.
And the basic, what they call basic math is trigonometry. That to them is a very basic math. So, you know, learning your algebra and your geometry and trig and all of these different things will help in all of these courses. Design and technology, you know, if you like art, learning how to do computer aided design, whether it's on Onshape or other CAD programs, is a huge thing. And in addition to that, also all of the e-learning, all of the gaming, all of those different things really create an incredible opportunity for your programming and your artistic side of things. And then once again, computing and programming in general are all really great fields to go into when you're looking into either robotics or artificial intelligence, machine learning. All of these are huge fields that are coming up, and many of these jobs, maybe even more than half of these jobs, haven't even been created as of yet. So what questions do you guys have about any of these areas or fields? What would you like to know more about?
You can go ahead and turn on your mics to ask questions. Or you can go ahead and put them in the chat if that makes it easier.
Hold on, I have for the student. Go ahead.
If I wanted to like design video games, how would I do it?
All right, so we have some questions about video game design. How do we get started? That sort of path.
So for video game design, there's a lot of different programs out there. A lot of common ones are Unity and Unreal. So let me see if I can share my screen again. Here. So video game design is actually very similar to normal programming. So it has as we saw earlier, it has this type of programming. This is called node programming. This is their visual type scripting. You can start with this and either Unity or Unreal. Each of them run their different type of code. One runs C# and C# and C++, which is, they're a bit different. They're very, very similar in running it, but C# and C++ are like slightly different in their syntax and how they use different commands.
You'll also, if you do a simple Google search, and we can also send out for all of you guys a bunch of different resources as well. But if you do a Google search, there's tons of free training available. Or if you want to spend just a small amount of money, you could use resources like Coursera or edX and different places like that that can get you started in those different types of courses. But it doesn't matter what age you are at this point. I mean, you could, in high school, you could easily become a master at that. And we've encouraged Ramsey on many occasions to, you know, find different programming. And quite frankly, if you want a part-time job that pays, you know, $25, $30, $40 an hour, learn to do things like Photoshop really well,
and some sort of video editing software,
or video editing software, because people will pay you a lot of money if you're good at it. And Camtasia is a great video editing software that you could learn very easily.
But going back to the video game design, you can use Unreal and Unity. They provide their own lessons, and they're also free until you make a profit. And then Blender, which is a modeling software, is also free. So that's how you could start with video game design.
What's another question?
Thank you for the information about video games. My class doesn't have any more questions right now. Thank you.
All right, thank you.
Thank you.
So Ramsey, what are your future plans?
Oh, well, short term, which means next 2-3 years, I plan on getting my robotics team top 5 in the world. When we were in FOL, we got an international bid, so we were close, but COVID kind of screwed that up. So that's my plan for robotics, and then I want to move on, and then in college I want to get a master's in robotics. Robotic engineering. I don't remember the exact term. And I want to get a doctorate in mechanical engineering.
Wow, that's awesome. So do you know anything about the scholarships offered through First Lego League?
Through First Lego League, I do not know any. I don't know much about through First.
I can do a little bit about that, but I would say there are over, I believe, $1 billion in scholarships that First Inspires provides access to. And I do know that all of the different colleges and all of the different individuals really emphasize, you know, theory is great, but practical application is important. You can think that you know how to put a robot together, but until you actually put it together and run it on a field, you don't realize what you don't know. And so the more hands-on experience that you can get, and First is an incredible program for you to get that hands-on experience, that the better. And First, like I said, offers many different scholarship programs, and they also have a lot of collaboration with a lot of different universities around the country.
Well, I know UCF has a robotics team. I was able to see their robot and see it in action. It was really, really cool, which was really exciting to be able to see theirs. And I know there are scholarships out there. So that's thank you for that information. And I'll make sure I get some more detailed information about that. But as you were saying, the practical experience and having those skills, we had St. John's State College on Tuesday present, and they were talking about how important it is to have those skills because some companies, such as Google, will hire you off of the skills you have, even
Absolutely.
if you do not have the college degree.
Absolutely. And if you can get any kind of internships, I know Ramsey is hoping to get an internship through our
Rankin Handmade Manufacturing, which is the machine shop that is sponsoring us and mentoring us. So I'm excited for that one.
so seeing if you can talk to anybody in computer design or gaming or any of those things. There's all kinds of different opportunities where you can work with them, and maybe you don't get paid, but let me tell you, that experience that you get is going to really pay off in spades going forward.
Awesome. Thank you so much. That was amazing. So much great information. I'm sure the students got a lot out of that. And we will be in touch.
All right.
That robotics team started out there at Crescent City High School. So students,
Absolutely.
if you are interested, please tell your teachers so they can go ahead and give me your information and we can get that started for you out there. Thank you so much. And
Thank you for having us.
I hope everyone has a wonderful day.
All right.
Yes.
Thank you. Bye-bye.
Bye.